In the darkness of the cosmos, long before humans, long before life, even long before the Earth itself existed, there was only dust, gas, and the endless silence of a young universe. Yet hidden in that silence were the seeds of creation, the raw ingredients that would one day assemble into our extraordinary planet. What forces brought together this cosmic chaos into the beautiful and dynamic world we now call home? How did Earth evolve from a barren sphere of molten rock into a planet teeming with life, oceans, forests, and intelligent beings capable of questioning their own origins? Our journey begins with a question as old as humanity itself. Where did our world come from, and how did it become what it is today? The answer is a story of violence and beauty, destruction and rebirth, chaos and harmony. It is the Odyssey of the Earth, an epic tale that spans billions of years, countless transformations, and mysteries that scientists are still unraveling today. Close your eyes and imagine. A planet not yet born, a solar system not yet ordered, only swirling clouds of stardust drifting across space. That dust once belonged to ancient stars, stars that lived and died long before our sun. Their fiery deaths scattered heavy elements, carbon, oxygen, iron, silicon, into the void. Without those stars, Earth would never exist. We are, in the most literal sense, the children of stars. The stage is set. A nebula of gas and dust, gently rotating, slowly collapsing under its own gravity. At the heart of this collapse, a spark of fusion ignites. A newborn star is born, our sun. Around it, the leftover debris spins, colliding, sticking together, growing larger. Tiny grains become pebbles, pebbles become rocks, rocks become worlds. And in that cosmic dance of collisions and destruction, Earth emerges, raw and fiery, a molten sphere glowing red against the darkness of space. The early Earth is unrecognizable compared to the world we know. Its surface is a hellscape of magma oceans, volcanic eruptions, and relentless bombardment from asteroids and comets. Each impact reshapes the young planet, melting rock, releasing gases, and adding water and minerals. This was a violent childhood, one that forged Earth's very identity. Yet in this chaos, the foundation for life itself was being prepared. One colossal event changed everything. A titanic collision with a Mars-sized body we now call Theia. The impact was so catastrophic that it nearly tore the planet apart. Debris from Earth and Theia was thrown into orbit, where it coalesced into a companion that still graces our skies today, the Moon. This impact also tilted Earth's axis, giving rise to the seasons and stabilizing the planet's climate for billions of years to come. From violence was born balance, and from destruction, creation. As Earth cooled, the surface hardened into crust, gases vented into the atmosphere, and rains began to fall. For millions of years it rained without end. The steam condensed, filling basins and craters, creating the first oceans. Water, one of the most vital elements for life, was now a permanent resident of Earth. And in those oceans, something miraculous was about to happen. Deep beneath the waves, at hydrothermal vents, where mineral-rich waters erupted from the seafloor, chemistry and geology conspired. Simple molecules assembled into complex chains. From lifeless matter, the first whispers of biology began. No one knows the exact moment or place, but somewhere, sometime, a spark of life emerged. Tiny cells, fragile yet persistent, became Earth's earliest inhabitants. They were simple, microscopic, but revolutionary. These first cells fed on chemicals in their environment, multiplying and diversifying. Over millions of years, They learned new tricks, ways to harvest energy from sunlight, ways to build stronger structures, ways to cooperate. Life was patient, life was creative, and life was resilient. For nearly 3 billion years, Earth remained a microbial world, invisible to the naked eye but alive with microscopic activity. Then came one of the most profound revolutions in Earth's history: photosynthesis. Tiny organisms discovered how to capture sunlight and turn it into energy, releasing oxygen as a byproduct. At first, this oxygen was toxic to much of life, but slowly it accumulated in the atmosphere, transforming the planet forever. The skies turned blue, the oceans oxidized, and the Earth prepared itself for something greater: complex life. The stage was set for an explosion of diversity. Single-celled organisms gave rise to multicellular beings. Simple colonies evolved into creatures with tissues, organs, and nervous systems. In the oceans, bizarre forms swam and crawled: trilobites, worms, sponges, and early predators with jaws and eyes. The Cambrian Explosion, as scientists call it, filled Earth's seas with life forms of dazzling variety. The blueprint of modern animals was established here 500 million years ago. But Earth's Odyssey was never simple. It was marked by cycles of triumph and catastrophe. Entire ecosystems flourished, only to be destroyed by mass extinctions. Ice ages turned the planet into a frozen sphere. Supervolcanoes poisoned the air. Asteroids crashed down, wiping out countless species. Yet every crisis was also an opportunity. Life rebounded, adapting, innovating, and diversifying in ways it never had before. From the seas, life began to explore the land. Plants were among the first pioneers, spreading across barren continents, transforming the atmosphere with even more oxygen. Insects followed, buzzing, crawling, and flying, becoming the most diverse creatures on Earth. Amphibians crawled out of the swamps, bridging the gap between water and land. Reptiles rose, conquering deserts and forests. Dinosaurs ruled for over 150 million years, dominating Earth's ecosystems with size and strength unmatched. But even the mighty fall. 66 million years ago, a mountain-sized asteroid struck the Yucatan Peninsula, unleashing an apocalypse. Forests burned, skies darkened, and the reign of the dinosaurs ended in fire and dust. Yet out of the ashes, a new lineage rose: mammals. Small, nocturnal creatures that had lived in the shadows now flourished. They diversified, grew larger, and took on every ecological role left vacant by the dinosaurs. From those mammals came primates. From primates, apes. And from apes, a species unlike any other, one capable of language, imagination, and curiosity: humans. With us, Earth's story took a new turn, one shaped not only by natural forces but by culture, technology, and thought. Today, as we gaze at our planet from space, we see not just a world of continents and oceans, but the living legacy of 4.5 billion years of cosmic evolution. Earth is a miracle forged from stardust, sculpted by fire, transformed by water, and animated by life. It is our home, fragile and resilient, ancient and ever-changing. Picture the Earth, nearly 4 billion years ago. The oceans are vast, the continents mere embryos of land beginning to rise from the depths. Volcanoes spew fire, ash, and molten rock into the skies, reshaping the land masses again and again. Lightning crackles through heavy clouds, rain falls in endless torrents, and the surface is a restless theater of change. The world is young, unstable, but filled with promise. Beneath these stormy skies, in shallow seas warmed by volcanic heat, life continues its slow but steady march. Simple cells dominate, yet their persistence tells us something profound. Life is tenacious. These organisms endure conditions so extreme that to us, they seem inhospitable. Acidic waters, boiling vents, radiation from an unforgiving sun, all are part of their daily struggle. Yet rather than fading, they thrive, adapting and laying the groundwork for everything that would come after. Scientists believe that these early organisms exchanged genetic material in ways alien to us today, creating vast networks of diversity. Slowly, new solutions emerged: stronger membranes, more efficient energy capture, the ability to live in different niches. The biosphere of Earth was still invisible to the eye, but it was already shaping the chemistry of the entire planet. Then, in what we now call the Great Oxidation Event, life's experiments produced a world-changing innovation. Photosynthetic bacteria, tiny architects of destiny, began to split water molecules using sunlight, releasing oxygen into the environment. At first, the gas combined with iron in the oceans, staining sediments into the rusty red layers we still see in rocks today. But as time went on, oxygen escaped into the air, transforming the atmosphere forever. This was both a catastrophe and an opportunity. For many organisms of the time, oxygen was poison. Entire lineages perished in what we might call the planet's first mass extinction. Yet for others, oxygen became the key to new levels of energy, enabling greater complexity. From this duality, death for some, life for others, the stage was set for multicellular existence. For billions of years, Earth remained primarily microbial, but patience, once again, yielded wonders. Somewhere around 2 billion years ago, cells began to cooperate in new ways. Some engulfed others, forming symbiotic partnerships that gave rise to mitochondria, the tiny powerhouses inside almost every cell of our bodies today. This leap made complex multicellular life possible. Slowly, life forms began to grow larger, to specialize, to become visible. Imagine oceans teeming with soft-bodied creatures, strange alien forms drifting through currents. In the Ediacaran period, around 600 million years ago, organisms resembling fronds, discs, and segmented mats populated the seafloors. They were unlike anything alive today, a failed experiment in some ways, but a crucial stepping stone toward the creatures that would follow. Then came a dramatic turning point, the Cambrian Explosion, roughly 541 million years ago. In a geologic blink of an eye, life diversified on an unprecedented scale. Suddenly, the oceans filled with predators and prey, with shells, claws, eyes, and spines. It was as if evolution, after billions of years of quiet preparation, had thrown open the gates of creativity. Trilobites scuttled across seafloors, armored like living tanks. Anomalocaris, with grasping appendages and gaping jaws, terrorized smaller creatures. Sponges filtered water, worms burrowed into sediments, and corals began to build the reefs that still flourish today. Virtually every major body plan that exists in animals appeared during this time, setting the blueprint for the diversity of life we see now. As life experimented in the oceans, the Earth itself was also undergoing colossal changes. Supercontinents formed and split apart, driven by the restless motion of tectonic plates. Mountains rose and eroded. Volcanoes erupted, altering climates and chemistry. The atmosphere thickened with oxygen, and ozone formed a protective shield against harmful radiation, allowing organisms to survive closer to the surface and eventually on land. Plants were the first pioneers to venture ashore. Simple, moss-like forms clung to damp rocks. spreading slowly across barren landscapes. Over millions of years, they evolved into vascular plants, capable of transporting water through stems and leaves. These pioneers transformed deserts into green carpets, pumping more oxygen into the atmosphere and creating habitats for future land animals. Where plants went, animals followed. Insects appeared, buzzing and crawling across the greenery. Amphibians evolved from lobe-finned fish, pushed their bodies onto land, breathing air through primitive lungs. They became the first vertebrates to truly straddle two worlds, water and land. Earth was no longer an ocean planet. It was a planet of forests, rivers, and swamps, alive with creatures. But life on Earth has always been fragile, forever balanced between creation and catastrophe. Throughout this Odyssey, crises struck again and again. The late Devonian extinction decimated marine ecosystems. The Permian extinction, the most severe in Earth's history, wiped out more than 90% of all species. For a time, life teetered on the edge of annihilation. Yet life persisted. Out of the Permian devastation, reptiles rose to dominance, diversifying into forms that conquered every environment. Among them were the ancestors of the dinosaurs, creatures that would define the Mesozoic Era. For over 150 million years, dinosaurs ruled the Earth with astounding variety. From gentle giants like Brachiosaurus to ferocious predators like Tyrannosaurus rex. Birds, too, trace their origins to these ancient reptiles, a living legacy of their reign. But as we know, dominance never guarantees permanence. 66 million years ago, a massive asteroid struck Earth, ending the age of the dinosaurs in an instant. Firestorms raged, skies blackened, and ecosystems collapsed. The catastrophe cleared the stage for mammals, those small, furry survivors who had scurried in the shadows of dinosaurs to take center stage. And so began the next act of Earth's Odyssey, an age that would ultimately give rise to us. Mammals diversified rapidly, filling niches left empty by the vanished giants. Some took to the seas, evolving into whales and dolphins. Others became grazers, predators, primates. Among the primates, a lineage of upright walkers eventually emerged, carrying the seeds of intelligence and curiosity that would reshape the planet like no species before. Today, as we look back on this vast timeline, it is almost overwhelming to comprehend. From stardust to magma, from single cells to dinosaurs, from extinctions to humans, Earth's history is a saga of constant transformation. Every layer of rock, every fossil, every ripple in the landscape is a page in this story, written over 4.5 billion years. And yet, this is only the beginning of our exploration. For the deeper we look into Earth's past, the more secrets we uncover. Secrets about how fragile our world is, how resilient life can be, and how connected we are to the forces that shaped everything around us. The Earth's surface is never still. Beneath our feet, massive slabs of rock, tectonic plates, drift and collide, reshaping the face of the planet over millions of years. Continents merge into supercontinents, then tear apart into new arrangements. Mountains rise where plates crash together, only to be worn down by wind and rain, their sediments carried into oceans that will someday rise again as land. It is a restless cycle, one that has played out countless times in Earth's history. One of the most famous of these arrangements was Pangea, a colossal supercontinent that dominated the world around 300 million years ago. Imagine a single landmass stretching from pole to pole, surrounded by a vast ocean. Within Pangea's interior, climates varied from lush forests to arid deserts, creating both opportunities and challenges for life. Reptiles thrived in these shifting environments, diversifying into many forms, some of which would become the ancestors of dinosaurs. But Pangea's unity was temporary. Beneath the surface, molten currents pulled and stretched the crust until cracks formed. Slowly, over tens of millions of years, the great supercontinents split apart, giving birth to the continents we recognize today. This splitting reshaped climates, redirected ocean currents, and triggered evolutionary changes that rippled through ecosystems across the globe. As dinosaurs reached their golden age, Earth's landscapes flourished with extraordinary diversity. Vast conifer forests towered over the land. Ferns and cycads blanketed the ground. Flowering plants, a revolutionary innovation in the plant kingdom, appeared in the Cretaceous period, bringing new relationships with insects and pollinators that transformed ecosystems forever. The world was alive with color, sound, and motion. The oceans, too, were vibrant kingdoms. Marine reptiles like ichthyosaurs, plesiosaurs, and mosasaurs ruled the seas. Ammonites, with their spiral shells, drifted in great numbers, while fish evolved sleek, powerful bodies to escape predators. Coral reefs flourished, providing havens for countless species, much like they do today. But Earth's history is not just about life. It is about death on a massive scale. Extinction events punctuate the timeline, acting as both devastations and catalysts. Each time, the balance of life shifts dramatically. When the asteroid struck 66 million years ago, dinosaurs disappeared, but mammals rose. When earlier extinctions wiped out dominant species, survivors adapted, giving rise to entirely new worlds of biodiversity. From the perspective of deep time, extinction is not the end. It is a turning of the page. Life, though scarred, always finds a way to continue. This resilience is perhaps Earth's most remarkable trait. As the Age of Mammals began, Earth entered a new chapter. Forests and grasslands expanded, climates fluctuated, and new species filled the landscape. In Africa, small primates leapt through the trees, their hands capable of grasping, their eyes forward-facing, their brains larger than those of other animals their size. These primates would set the stage for a remarkable evolutionary experiment. Over millions of years, some primates adapted to life on the ground. They stood more upright, walked on two legs, and freed their hands for tools and gestures. With these adaptations came intelligence, communication, and eventually culture. Our ancestors began to shape their environment in ways no other species had done before. They harnessed fire, crafted tools, painted caves, and told stories. But humanity's rise is just the latest flicker in Earth's vast timeline. If we compressed Earth's 4.5 billion years into a single day, life would not appear until early morning. Dinosaurs would dominate around 10 p.m., and humans would arrive only seconds before midnight. Our existence is but a breath in the grand Odyssey of the planet. Yet in that breath, we have transformed Earth more rapidly than almost any natural process. We have built cities, dammed rivers, cleared forests, and changed the climate. We are, for the first time, a species capable of altering the trajectory of the entire planet. This realization forces us to look back at Earth's story with new eyes. The catastrophes of the past, asteroid impacts, volcanic eruptions, ice ages, were acts of nature. But today, we are the agents of change, The future of this Odyssey may depend on the choices we make. Still, the deeper story remains one of awe. From a swirling nebula of stardust, Earth emerged. From a molten ball of rock, it cooled and formed oceans. From oceans, life arose. From life, intelligence emerged, capable of asking the question, how did we get here? Every rock and fossil carries a fragment of this answer. The cliffs that reveal ancient seabeds, the ice cores that trap bubbles of ancient air, the meteorites that hold traces of the solar system's birth, all are pieces of the puzzle. Together, they remind us that Earth is not static, but dynamic, alive with motion and transformation. As we look toward the future, we may wonder, what comes next? Continents will continue to drift, perhaps forming another supercontinent millions of years from now. New species will evolve, others will vanish. The sun itself will change, growing brighter over time, eventually rendering Earth uninhabitable. But that is billions of years away, and between now and then lies untold possibility. For us here and now, Earth is a sanctuary, a fragile oasis in the vast emptiness of space. Its history is our inheritance. Its future, in many ways, is our responsibility. We are part of the Odyssey, not separate from it. Every breath we take carries oxygen, released by ancient photosynthetic organisms. Every cell in our body holds mitochondria, descendants of ancient symbiotic bacteria. Every bone in our skeleton is shaped by evolutionary trials, millions of years old. We are walking history, living archives of Earth's grand experiment. Perhaps this is the most profound lesson of all. Earth's story is not just the story of rocks, oceans, and climates. It is the story of us, not as conquerors of the planet, but as threads woven into its fabric. The more we understand this, the more we can live not in opposition to Earth's processes, but in harmony with them. The Odyssey of the Earth is a reminder of fragility, resilience, and transformation. It is a saga of unimaginable time, where every ending became a beginning, and every crisis sparked new life. It is a story still being written, with each sunrise, each storm, each new generation. And as we continue to explore it, we find not only the history of our planet, but the history of ourselves. Across billions of years, Earth has endured cycles of fire and ice, of creation and destruction. Yet with every upheaval, with every transformation, the planet has found a way to renew itself. This resilience is part of its identity, written into every mountain range, every canyon, every fossil buried beneath our feet. Consider, for a moment, the forces that shaped the landscapes we know today. The Grand Canyon in Arizona reveals nearly 2 billion years of history in its layered rocks, each stratum a frozen memory of ancient seas, deserts, and rivers. In Iceland, geysers and volcanoes remind us that Earth is still alive, still reshaping itself from within. In Africa's Rift Valley, tectonic forces are literally pulling a continent apart, creating a glimpse of oceans that will form millions of years from now. These landscapes are not static scenery. They are chapters of the Earth's Odyssey. They remind us that our world is in constant motion, even if we cannot see it in the span of a human lifetime. The continents drift a few centimeters each year, barely noticeable to us, but unstoppable across millions of years. Life, too, mirrors this motion. From single-celled organisms to the complexity of ecosystems, evolution is Earth's heartbeat. It is not a linear march toward perfection, but a branching, unpredictable dance of adaptation. Every species alive today is the result of an unbroken chain of survival, stretching back to the very first cell that ever lived. Some of the greatest dramas in this evolutionary dance are the mass extinctions. The Permian Triassic extinction, about 252 million years ago, remains the most catastrophic. Often called the Great Dying, it erased over 90% of marine species and 70% of land species. Entire ecosystems vanished, leaving Earth nearly barren. For millions of years afterward, recovery was painfully slow. Yet eventually, life surged back, reshaped, reimagined, renewed. From this devastation, the age of reptiles rose. The Triassic period saw the first dinosaurs appear, small and unassuming at first, but destined for greatness. By the Jurassic, they towered over the land, filling forests and plains with giants whose bones we still unearth today. Their reign lasted longer than the time that separates us from the first humans, a reminder of the vastness of deep time. But while dinosaurs ruled the land, tiny mammals endured in the shadows. They were small, nocturnal, and easily overlooked, but they carried traits that would one day change the world: warm blood, live birth, nurturing care for their young, and adaptability to diverse environments. These humble survivors are proof that dominance does not guarantee permanence, and obscurity does not mean insignificance. When the asteroid struck 66 million years ago, it obliterated the dinosaurs' world. Yet for mammals, it was a door opening. Freed from predators and competitors, they radiated into every niche: grazers, hunters, climbers, flyers. Whales returned to the oceans, bats to the skies, elephants to the savannas. And eventually, among them, primates developed minds capable of reflection, of memory, of imagination. But to understand humanity's place in Earth's Odyssey, we must look not only at evolution, but also at climate. Throughout its history, Earth's climate has swung dramatically between extremes. There were times when ice covered nearly the entire planet, creating what scientists call Snowball Earth. There were also times when lush tropical forests flourished at the poles. Climate is the stage upon which life evolves, shaping opportunities and challenges, extinctions and adaptations. The rise of grasses, for example, transformed entire ecosystems. Around 10 million years ago, vast grasslands spread across continents, creating new habitats and diets. Herbivores evolved teeth to grind tough grasses, while predators adapted to chase prey in open plains. Among these shifting environments, early humans began their journey. Standing upright, with free hands and expanding brains, they learned to survive on landscapes that demanded ingenuity. Our ancestors did not walk alone. They shared the earth with giant creatures: mammoths, saber-toothed cats, giant sloths. These animals, like the dinosaurs before them, lived in worlds that vanished with time. Yet humans endured, not because of size or strength, but because of adaptability, cooperation, and imagination. And with imagination came something Earth had never seen before: a species capable of contemplating its own history. We look at fossils and see reflections of ourselves. We gaze at the stars and recognize the atoms of our bodies. We study the rocks beneath our feet and uncover the story of oceans that disappeared billions of years ago. We are not only part of the Odyssey, we are storytellers of it. Still, humanity's impact is unprecedented. In a few centuries, we have altered the face of the planet as profoundly as some natural disasters. Forests have been cleared at rates unseen since the last great extinctions. Rivers have been dammed, deserts expanded, species pushed to the brink. Carbon dioxide levels have risen to heights not experienced in millions of years. We have become a force of geology ushering in what many scientists call the Anthropocene, a new chapter in Earth's history defined by human influence. And yet, even as we change the Earth changes us. Our cities are vulnerable to rising seas. Our crops depend on stable climates. Our health relies on ecosystems. We are not outside the system. We are woven into it, as dependent on the rhythms of the planet as the first microbes were on their vents. So, as we look back at this 4.5 billion year Odyssey, we also look forward. What choices will we make as inheritors of such a history? Will we learn from Earth's cycles of resilience? Or will we ignore the warnings written in stone and ice? For all its catastrophes, Earth has always recovered. Life has always found a way. The question that lingers is whether we will remain part of that resilience, or whether we will write ourselves out of the story. Perhaps that is the greatest responsibility we hold, to recognize that Earth is not simply our backdrop. It is our origin, our sustainer, and our future. Every sunrise, every storm, every tree and river is a continuation of a journey that began billions of years ago in the heart of dying stars. To protect Earth is not only an act of survival, it is an act of honoring the Odyssey that made us. And so, as the camera pulls back, revealing the swirling blue marble suspended in the blackness of space, we are reminded of our fragile place in the cosmos, a single world, unique and vibrant, carrying within it the story of time itself. This is Earth's Odyssey, a story still unfolding, a story that belongs to us all. Earth's story is a symphony of interconnected forces. No part of its history exists in isolation. The movement of continents alters climate. Climate shifts open or close doors for life. Life, in turn, reshapes the atmosphere and the land. Every chapter of Earth's Odyssey is written not by a single hand, but by the ceaseless interplay between geology, biology, chemistry, and time. One of the most profound examples of this interplay lies beneath our feet in the carbon cycle. For hundreds of millions of years, Earth has regulated its climate through a delicate balance of carbon dioxide moving between the atmosphere, oceans, rocks, and living organisms. When volcanoes erupt, they release carbon into the air. When plants grow, they capture it, storing it in their tissues and eventually in soils. When shells and skeletons sink to the ocean floor, carbon becomes locked away in stone. This silent cycle has stabilized Earth's climate, keeping it habitable even as the sun slowly grew brighter over time. Without it, Earth might have swung wildly between extremes, too frozen or too hot for life to endure. And yet, balance has never meant perfection. There were times when the cycle faltered, when massive volcanic outpourings flooded the skies with greenhouse gases, warming the planet dramatically. At other times, carbon was drawn down so much that glaciers spread across continents. Each shift forced life to adapt, to transform or perish. Earth's Odyssey is not gentle, it is relentless, demanding resilience from all who inhabit it. The rise of oxygen was one such turning point. Before it, life was confined to simple forms, relying on chemical reactions that yielded little energy. With oxygen, organisms could unleash powerful metabolisms, fueling complexity. Muscles, nerves, movement, all became possible. This invisible gas, toxic to early microbes, became the breath of higher life. It reshaped evolution, gave us the skies we know, and eventually filled our own lungs with every inhale. Water, too, has been a constant sculptor of Earth's destiny. From the rains that carved canyons to the tides that shaped coastlines, water is both a destroyer and a giver of life. The ocean's moderated climate absorbed heat and provided a cradle for evolution. They remain the heart of our planet today, covering more than 70% of its surface, circulating currents that distribute warmth and nutrients across the globe. Without oceans, Earth would be a barren desert, unrecognizable to us. Through deep time, oceans have risen and fallen countless times. During ice ages, vast sheets of ice locked away water, lowering sea levels and exposing land bridges that allowed species to migrate between continents. During warmer periods, ice melted, seas rose, and coastlines drowned. These changes redrew maps, shifted ecosystems, and guided the paths of evolution. Our own ancestors crossed such land bridges, migrating out of Africa, spreading across Asia, Europe, and eventually into the Americas. In this way, Earth's rhythms directly shaped human history. The atmosphere has been another actor in this epic. More than a shield against radiation, it is a dynamic system that controls weather and climate. Storms, winds, and currents are not random chaos. They are the planet's way of redistributing energy. From the monsoons of Asia to the hurricanes of the Atlantic, these forces have dictated where civilizations thrived and where they struggled. The fertile crescent of Mesopotamia depended on river floods. The collapse of the Maya may have been tied to droughts. Earth's breath has always whispered through the fate of humanity. But perhaps the most humbling perspective comes when we realize how rare and precious Earth's conditions are. In our solar system, no other planet offers the same combination of atmosphere, liquid water, and chemical richness. Venus is a furnace, its skies choking with carbon dioxide. Mars is frozen, its rivers long dry. Earth alone has struck the balance, a balance so delicate that a slight change could tip it toward sterility. This fragility makes Earth's resilience all the more remarkable. For 4.5 billion years, despite asteroid impacts, volcanic winters, and global freezes, life has endured. No catastrophe has ever fully silenced the pulse of evolution. Even at the darkest moments, survivors adapted, multiplied, and began anew. Life, it seems, is not just a passenger on Earth's Odyssey. It is a driver, an agent of change as powerful as tectonics or climate. Consider the arrival of forests. When plants grew tall and deep-rooted, they transformed the land. They stabilized soils, slowed erosion, and created entire ecosystems. They also drew vast amounts of carbon from the atmosphere, cooling the climate. In time, their remains accumulated underground, becoming coal, fuel that humans would one day ignite, altering the climate once again. The story of forests is a reminder that life does not merely react to Earth's environment, it reshapes it in profound ways. The same is true of coral reefs, those living fortresses of the sea. Built from the skeletons of tiny organisms, reefs provide shelter for countless species, protect coastlines, and influence ocean chemistry. Over geologic time, reefs have appeared and vanished, rising with warm seas, crumbling when climates shifted. Each cycle is another verse in Earth's symphony of creation and loss. Now, in the present, humanity faces the paradox of being both product and shaper of this Odyssey. We are the children of stardust, the heirs of billions of years of survival. Yet we also carry the power to disrupt the cycles that nurtured us. Our industries pour carbon into the air faster than natural processes can absorb it. Our expansion consumes habitats at a rate unseen in history. We are accelerating change, and in doing so, we must ask, What role do we want to play in the next chapter of Earth's story? Looking at Earth from space, astronauts describe a profound shift in perspective. The overview effect. They see a fragile blue sphere with no borders, no divisions, only a single living system. From that distance, Earth appears both resilient and vulnerable, ancient and fleeting. It is a reminder that while the Odyssey is vast, our place within it is intimate and precious. And so, the narrative circles back to its beginning. From the ashes of stars, Earth was born. From fire and ice, it forged oceans and skies. From molecules, it birthed life. From extinction, it gave rise to resilience. From simplicity, it created consciousness. This is not merely a history. It is an epic of transformation, a reminder that change is the only constant, and that within change lies the possibility of renewal. The Odyssey of Earth is still unfolding. Somewhere, in the depths of the ocean or the silence of the forest, life continues to adapt, to write new chapters unseen. Somewhere, in laboratories and observatories, humans continue to unravel the mysteries of our origin. Somewhere, in the choices we make each day, we determine whether we will harmonize with Earth's cycles or push against them. One truth endures. Earth is not finished. Its story stretches far into the future, long beyond us, long beyond the civilizations we build. In time, continents will merge into another supercontinent. New species will rise, others will vanish. The sun itself will one day grow, changing everything. Yet the Odyssey will continue, carried by the same forces that have shaped it since the beginning. And as we reflect on this journey, we realize that to know Earth is to know ourselves. Its past is our past. Its future is bound to our future. We are not apart from its Odyssey. We are its latest verse, fragile and fleeting, but capable of giving meaning to the whole. If Earth's Odyssey teaches us anything, it is that time is the true architect of worlds. Our lives, measured in decades, are but fleeting moments against the billions of years etched into stone. Yet within those stones lies a record, an archive written by ancient seas, volcanic ash, drifting glaciers, and vanished forests. To read this record is to glimpse the deep memory of our planet. Consider the fossils of stromatolites, layered structures built by microbial mats more than 3 billion years ago. They whisper of the earliest architects of life, tiny organisms whose collective activity changed the chemistry of the world. Or the footprints of early tetrapods pressed into mud 375 million years ago, marking the bold steps of creatures venturing onto land for the first time. Each imprint, each fossil, is a frozen echo of life's courage to adapt and transform. The Earth itself is a storyteller. Its mountains rise like exclamation marks. Its valleys sink like pauses in a sentence. Its rocks unfold like pages written in lava, sand, and clay. When we study geology, we are not merely examining minerals. We are listening to Earth speak across time. And what it tells us is often dramatic. Supervolcanoes like those beneath Yellowstone or Indonesia have erupted with forces unimaginable, cloaking skies in ash, plunging the planet into years of volcanic winter. These cataclysms tested the resilience of life, pushing species to their limits. Yet, as always, survivors emerged, and new ecosystems rose where old ones had fallen. Asteroid impacts, too, left scars upon the surface and upon history itself. The crater at Chicxulub in Mexico is not just a hole in the ground. It is a wound that ended the Age of Dinosaurs and gave mammals their chance. Each impact, each eruption, each shifting plate reminds us of Earth's restless nature, a planet never content to remain unchanged. Through these upheavals, evolution was both sculptor and survivor. After every crisis, the survivors were not simply weaker or stronger. They were different. They bore new traits, new strategies, new possibilities. Evolution is not about perfection, but about persistence, about meeting the demands of the moment. It is a process of endless trial and error, where the only constant is change itself. The rise of primates demonstrates this truth beautifully. From small tree-dwelling mammals, primates developed grasping hands, binocular vision, and social structures. These traits did not make them dominant at first, but they prepared them for a future where adaptability was everything. When climates shifted and forests gave way to grasslands, some primates left the trees. Walking upright, they freed their hands, expanding their ability to create, to use tools, to communicate. From these first bipedal steps came a lineage that would one day look back on the stars and wonder about its origins. Homo habilis, Homo erectus, Neanderthals, and at last Homo sapiens, all part of a branching tree shaped by survival, migration, and imagination. Each of our ancestors lived in landscapes shaped by Earth's rhythms. Ice ages, droughts, fertile valleys, and dangerous predators. And in each challenge, they found ways to adapt, passing on their resilience to us. But as humans grew in number and knowledge, they became something Earth had never seen before. A species able to alter its own environment deliberately, to bend the rhythms of nature to its will. Fire, agriculture, cities, these were not simply adaptations, they were revolutions. And with each revolution, our footprint grew. Until today, it stretches across every continent and every ocean. This unprecedented power forces us into a paradox. We are the product of Earth's Odyssey, yet we also hold the power to disrupt it. Climate change, deforestation, mass extinctions. These are not acts of geology or astrophysics, but of humanity. In a sense, we have become a new geological force, one whose choices ripple across ecosystems and centuries. Still, the Odyssey continues beyond us. Even if humanity vanished tomorrow, Earth would go on. Forests would reclaim cities, rivers would reroute, species would evolve to fill the void. The Odyssey does not depend on us, but we depend on it. That realization is humbling, and perhaps it should guide the way we live upon this world. Looking into the distant future, scientists predict transformations still to come. Continents will drift again, slowly merging into a new supercontinent, perhaps Amasia, forming near the North Pole, or Pangea Proxima, encircling the equator. Oceans will shift, climates will change, and ecosystems we cannot imagine will emerge. Farther still into the future, the sun itself will evolve. Growing hotter and brighter, it will eventually strip Earth of its oceans, turning our blue planet into a barren desert. Billions of years later, it will expand into a red giant, engulfing the inner planets, including Earth. Our world's odyssey will end, not with catastrophe, but with transformation into cosmic dust once again. And yet, in that final vision lies continuity. The elements forged in Earth will scatter into space, perhaps seeding new stars, new planets, new chances for life. The cycle that gave birth to us will begin anew elsewhere. In this way, Earth's story is not just about one planet, but about the universe itself, a cosmic odyssey without end. For us in the present, the Odyssey is a reminder of perspective. We are small in time and space, yet we are aware. We carry within us the memory of stardust, the legacy of survival, the power of imagination. Few species have been granted this gift, and with it comes responsibility. To care for Earth is to care for our own past and future. It is to honor the microbes that breathed oxygen, the plants that greened the continents, the ancestors who walked out of Africa. It is to recognize that every sunrise, every breath, every moment is part of a story billions of years in the making. So let us marvel, not just at what Earth has been, but at what it continues to be. A living planet, vibrant and dynamic, fragile yet enduring. Its odyssey is not finished. It carries on in the forests, in the oceans, in the skies, and in us. To witness it is a privilege. To protect it is a duty. And as the stars rise above a darkened horizon, we remember we are passengers on a journey that began long before us and will continue long after. The fascinating Odyssey of the Earth is not only the story of a planet, it is the story of life, resilience, and wonder itself. When we reflect upon the Odyssey of Earth, it becomes clear that this story is not one of straight lines, but of cycles. The planet breathes in rhythms, warm periods and ice ages, creation and destruction, expansion and collapse. These cycles are written into every corner of the world. Take the polar ice, for instance. Locked within layers of Antarctic and Greenland ice sheets are bubbles of ancient air, snapshots of Earth's atmosphere stretching back hundreds of thousands of years. They reveal patterns of rising and falling carbon dioxide, of glacial advances and retreats. From these frozen records, we learn that Earth's climate has always been dynamic, but also that small changes can tip the balance between frozen worlds and fertile lands. Glaciers themselves are storytellers. They carve valleys, grind down mountains, and leave behind moraines that mark their passage. In Europe and North America, entire landscapes were sculpted by the advance and retreat of ice sheets during the Pleistocene epoch. When the ice retreated, it left behind fertile soils, rivers, and lakes, foundations upon which human civilizations would later rise. The oceans, too, bear the memory of cycles. Corals grow in layers, like rings in a tree, recording changes in temperature and chemistry. Sediments accumulate on the seafloor, carrying pollen from ancient forests, dust from deserts, shells from plankton that once floated in sunlit waters. Each layer is a diary of Earth's shifting moods, waiting to be read. But cycles are not only physical, they are also biological. Evolution itself runs in waves. After every extinction, life rebounds with bursts of creativity, filling empty niches with new forms. After the dinosaurs vanished, mammals diversified into bats, whales, primates, and countless others. After the Permian extinction, reptiles and early amphibians found new ways to dominate the land. It is as if life, when pushed to the brink, responds with innovation. This resilience is why Earth remains vibrant today. Despite 5 major extinctions, despite asteroid strikes and volcanic winters, life has never truly surrendered. Instead, it has transformed, adapted, and reinvented itself in ways that continually astonish us. This, perhaps, is the core of Earth's odyssey, not just survival, but transformation. And yet, even as life persisted, it has never been free from the influence of Earth's deep processes. The drifting of continents, for example, has been a hidden hand guiding evolution. When South America drifted in isolation for millions of years, unique creatures like armadillos, sloths, and giant glyptodonts evolved, shielded from the predators of other continents. When the land bridge between North and South America formed 3 million years ago, Species crossed in both directions, reshaping ecosystems. Geography became